Okay, section 7.6, calculus, and center of mass. And now we're just going to take a little bit more general situation where I want to find the planar region of, some two functions here like this, and we'll call this one f of x, this one g of x, and we'll maybe cut them here. Now, this is convenient that we've cut them there, but they could have come together in a point, where they intersected each other. That would be fine. Maybe we'll look at something like that. Try a sine and a cosine or something along those lines. And so again, if I want to find the mass of this thing, well, now, what's my height? My height is just f of x minus g of x. And I can name that a new function, h of x. And if I did, then, what we do here will look just like the previous video. But in general, we can just take the top curve minus the bottom curve for our height. And we've got that times a density of rho. And again, I could put little xi's on here for a given spot, and then multiplied by my delta xi. And, well, we sum all those up. And so if this is a and that's b, we want an integral from a to b of rho n times our f of x minus g of x dx. And there we go. There's our, mass equals, and there's our mass. And now doing that same sort of thing with m sub y, remember that all that changed was, well, we found our mass here, so that piece was the same, but then, we found our moment by taking that xi. And so we just tossed an xi into the mix times all that, which just means we get rho, integral from a to b of x times f of x minus g of x dx. And there you go. Then for m sub x, let's kind of draw this thing again. We have this, there's f, there's g, and once again, gotta watch that. Once again, for m sub x, we're making the x-axis our origin from a linear standpoint. And so we can take a mass here, but our distance we're going to use is, again, that average of this whole height. And to get that average there, that point, that is going to be f plus g over 2. And we had f over 2 last time, and notice that our bottom curve was the curve y equals 0, so we had f plus 0 over 2. So it was the same thing. So here, our distance is f plus g over 2, but the mass is again the same. So we still have that rho. We still do an integral from a to b. We still have our mass. I'm going to leave some room here. F of x minus g of x dx. So that was our mass, but instead of this x for the distance this way, we're using the average of the two function values for our distance that way, toward the x-axis. And so that is f of x plus g of x all over 2. And that's where they get that formula. Okay, so there we have that. Okay, that is where the formula comes from. Now I suppose we could try this out with some simple areas just to check that, hey, we are getting the right sorts of answers. And so suppose I just do it with a rectangle. I'm going to have the rectangle come down below a little bit here. So we'll make that -1. We'll make that 3. And we'll make this at 2 and this at 6. Now, so I know if this rectangle, which is actually, I guess, a square, I know that its balance point is going to be right there in the center as long as the density is constant throughout. And so, I should get values of 1 and 4. Okay, so my x bar should be a 4 and my y bar should be a 1. And let's see if our formulas here make that work. Okay, well, so f of x is equal to the constant 3. G of x is equal to the constant -1. And m is rho times the integral from 2 to 6 of f of x minus g of x dx. So this is rho times the integral from 2 to 6 of 3 minus a -1. Yep, 3 minus -1 dx. So that's 4. So this is rho and 4, so we get 4x. And this is from 2 to 6. And so this is rho times 4 times 6 minus 4 times 2, which is 16 rho. Okay, so that's mass. M sub y. Okay, m sub y, remember, is just we take rho and then toss in an x. Whoops, I don't know what I just did, but toss in an x in front of our mass statement there. And so this is rho, the integral from 2 to 6, x times, and again we had just 4 in there, so I'm going to write that as 4x dx. So now we get rho, and this is, well, don't need that because I can do that antiderivative. That's 2x squared. Whoops. Maybe I can do that antiderivative, 2x squared, from 2 to 6. So this is rho times 2 times 36 minus 2 times 4. So that's 32 times 2, or 64 rho. And so that means our x bar is my over m. So 64 rho over 16 rho, which is 4. That's what we said there. So far, so good. Now our m sub x. Now again, for m sub x, well, we have the row, we have the integral from along the x-axis 2 to 6. And then, where was it? Oh, right here. Right, we still have the thing we did for mass, f of x minus g of x, but now we take the average of those two, f of x plus g of x, over 2. So get that average. So f of x plus g of x. So f of x was 3, g of x was -1, and divided by 2. But then we have our 4. And so we have 4 and dx. And again, the 4 just came from the 3 minus a -1. And so this is rho times the integral from 2 to 6. 3 minus 1 is 2, so we just get 1, and so that's just 4 dx. And so this is rho, and we've done this integral. Integral from 2 to 6 of 4, right here. Right, and we got 16 rho. So this is 16 rho. And so then when we take, when we want to find our y bar, that is our m sub x over m, which is 16 rho over 16 rho, or 1. And again, that's what we said it should be, 1. And so you see it worked out lovely for something we knew the answer to. And so that, again, that is where these formulas come from. And we'll call that video done.